Okay, hello and welcome back. In this video, we're covering section 7.2 on factoring trinomials of the form x squared plus bx plus c. Before we start doing this, we'll need to practice some arithmetic skills needed to perform this factoring. So let's see a couple examples. It wants us to find two integers in part A where the product is 15 and the sum is 8. What this means is we're trying to find two factors of 15. We can describe 15 as something times something, where when we add those two together, we get a positive 8. So we need two numbers whose product is 15, meaning they multiply to equal 15, and when we add them together, we get 8. So this takes a little bit of guessing and checking, and you'll start to build more of a skill for this the more times you get to practice. And we can always just go through and start listing the factors of 15 until we get something that works. Meaning I can start with 1. 1 times 15 is 15, but if I add them together, I get 16. 15 is not divisible by 2, but it is divisible by 3. 3 times 5 is 18. 3 times 5 is 15. And then notice when I add them together, 5 plus 3 is 8. So the two numbers I'm looking for is positive 3 and positive 5. Let's try another one. In part B, we want two numbers whose product is 24. So two numbers that multiply to 24, whose sum is negative 10. So notice here I want a negative sum, but a positive product. So that means my two numbers should be negative. For instance, if I have negative 1 and negative 24, a negative times a negative would give me my positive result. And then when I add them together, I'll get some negative sum. So when you get something like this, a positive product and a negative sum, it means that both numbers should be negative. So for our first guess, negative 1 plus negative 24 would be negative 25. So we want the sum to be negative 10. So how about negative 2? I know 2 times 12 is 24, so I would be doing negative 2 and negative 12. Adding those together, I would get negative 14. So we're closer, but not quite there. I know 3 times 8 is 24, so that would be negative 3 and negative 8. Adding those together, I would get negative 11. So still closer, but not quite. So how about 4 and 6? Negative 4, negative 6. Add those together and we get our negative 10. So the two numbers we're looking for are negative 4 and negative 6. Part C wants a product of negative 28, and the sum is 3, positive 3. So I have a negative product and a positive sum. This means that one should be positive and one should be negative. So that when I multiply them, I get a negative number, but when I add them, I'll want the larger number to be positive so that the result is still positive. So we could do negative 1 and positive 28, but that would give us 27. We could do negative 2 and 14, but that would give us 12. We want to get 3. 28 is not divisible by 3, but it's divisible by 4, so let's do negative 4 and positive 7. Notice when we add these together, we get positive 3. So the numbers we're looking for are negative 4 and positive 7. So this seems like kind of a weird thing to do, but it's directly applied in our factoring of a trinomial, like what was shown on that first slide. So in order to see this, let's just remember that factoring is kind of like reverse multiplication. Let's say we had something like x plus 4 times x plus 5, and we wanted to multiply this out. If two factors multiplied. Well, to do that, we would FOIL. So our first two terms multiplied would give us x squared. Then our outer two terms multiplied, x times 5, would give us 5x. Then the inner terms would be 4 times x. Then the last two terms are 4 times 5, so 20. And then let's combine those middle terms, and we get x squared plus 9x plus 20. So let's look at this 9 and look at this 20 and how they relate to the 4 and the 5. So notice that 4 plus 5 is 9, and 4 times 5 is 20. So when we are factoring, we're going to start with something like this, x squared plus 9 plus 20. And we're going to want to produce these two factors. So we're going to go in reverse. And what we'll be looking at is this third term, which we'll call the c term. These letters are coming from the general form x squared plus bx plus c. So b is just this one in the middle, c is the one at the end. So we'll be looking at this c term. In this case, it's 20. And we'll be doing like what we did in those previous examples. We want two numbers whose product is this number 20 and whose sum will be this b term, positive 9. In this case, it's 4 and 5. Once we find out what those numbers are, then we can write our two factors using these two numbers, 4 and 5. So we're like reverse engineering the foiling process. So let's read the text description, and then we'll get a bunch of problems to practice on. So it says, to factor a polynomial of this form, x squared plus bx plus c, find two integers whose product is the third term c and whose sum is the middle term b. Then it can be written as two factors with those two terms. And then there's a few notes on what should be positive and negative. And we saw that from our last example. So it says if b and c are positive, if everything's positive, then your two factors must also be positive. If c is positive and b is negative, that was our second case where both of your factors should be negative. That means they'll multiply to equal a positive number and add to be a negative number. If c is negative, then one of those factors should be positive and one should be negative to produce a negative number. And it says we can always check by multiplying our result out. So let's take a look at these examples and follow this process. We'll start with x squared plus 7x plus 12. And we're viewing it as this general form, x squared plus bx plus c. So in this first case, our c term is 12 and our b term is 7. So we're looking at factors of 12, so factors of our c term that add up to our middle term, 7. So we can just go through, we can think about what are factors of 12. Well, 1 and 12, but if I add those, I get 13. We have 2 and 6, but if I add those, I get 8. And then 3 and 4, sum of these is positive 7, which is what we want. So my two numbers are 3 and 4, which means that this will factor into x plus 3 times x plus 4. So you look at your C term, find two numbers that add up to your middle term, and then once you have those, you can build these two factors with your variable to the first power as the first position, and then these two numbers show up as the second term. And we can check by foiling this out. Let's try at least with this first one. The first terms is x times x, so we get x squared. Then the outer terms is x times 4, so plus 4x. Middle terms is 3 times x, and then 3 times 4 is 12. And then notice these middle terms will add up to 7x. So x squared plus 7x plus 12, which was our original statement here. So you can always double check your work by multiplying through. All right, there's a bunch of these, so let's get some more practice. Part B gives us p squared minus 9 times p plus 14. So our C term is 14, and our B term is negative 9. So I'm looking for factors of 14 that add up to negative 9. So that means these should both be negative. So I could start with negative 1, negative 14, that'll give us negative 15. Negative 2 and negative 7. Combining those together, we get negative 9. So those are the two numbers we want. Oops. So that means our two factors will be, this time p instead of x, minus 2 times p minus 7. All right, part C, we have w squared plus w to the first power minus 30. So we're looking for factors of negative 30. We have a minus 30, so the negative comes with it too. So minus 30, two numbers that multiply to equal negative 30, but when I add them, I get positive 1. Our B term is 1, since we just have one w. So that means one should be positive and one should be negative. I want a positive result when I add them together. So the smaller number should be negative, the larger number should be positive. So we can do negative 1 and 30, that'll give us 29. Negative 2 and 15, that'll give us 13. We could do negative 3 and 10, that'll give us negative 7, we're closer. It's not divisible by 4. How about negative 5 and positive 6? Add those together. They multiply to negative 30. If I add them, I get positive 1. So those are the two numbers I want. So that means this will factor into w minus 5 times w plus 6. All right, let's keep going. Part D. D is a squared minus 3a minus 54. So I'm looking for factors of negative 54 that add up to negative 3. So I got a negative result for the multiplication. So one should be positive, one should be negative. And when I add them, I want a negative number. So the larger number should be negative this time. So we can start with positive 1, negative 54. That won't give us a negative 3. 2, negative 27. That wouldn't work either. It's also divisible by 3. 3 times 18 is 54. So make the 18 negative. That'll give us negative 15. 54 is divisible by 6. 6 times 9 is 54. So we could do positive 6, negative 9. We multiply to give us negative 54, and then 6 minus 9 is negative 3. So you can always go through and just try dividing this number by like 1, 2, 3, 4, 5, 6, until you get something that works out. And then as you do this more and more, you'll start to be able to guess a bit more accurately as you start to see maybe some repeated situations. So that means this will factor into a plus 6 times a minus 9. Part E gave us c squared minus 6c plus 9. So we're looking for factors of positive 9 that add up to negative 6. So we got, let's see, they should both be negative, it looks like, because they multiply to equal a positive number and then add together to get a negative number. So they should both be negative. So we can try negative 1, negative 9, that'll give us negative 10. How about negative 3 and negative 3? Multiply those, we get positive 9, and when we add them together, that'll give us negative 6. So that means this will factor into c minus 3 times c minus 3. We have a repeated factor. So since it's the same, we can even write this as c minus 3 squared. I'll box both of these. Since we just have c minus 3 times itself, so we can write it as a squared factor. This is a special case. It's called a perfect square trinomial. And then part F gives us y squared plus 11y plus 35. So we're looking for factors of 35 that add up to positive 11. So what are our possibilities? We have 1 and 35. Definitely doesn't add up to 11. It's divisible by 5. 5 times 7 is 35. But that would add up to 12, so that's close. The next factor would be 7. And notice we just get 7 times 5 again. 7 and 5, so that adds up to the same. Then the next one wouldn't be until 35 and 1. So this gives us no results. Meaning there's no two, at least integer numbers that have this ability to multiply to equal 35 and add up to 11. That doesn't mean that this can't be factored, but it can't be factored with this method. So this will be a to be continued. We'll have to save this for maybe a later section or possibly college algebra. So that shows us that sometimes we won't always be able to find these two numbers. If you run out of factors, if you notice they start repeating, just flipped. We had 5 and 7, and then 7 and 5, and then 35 and 1. It starts to mirror itself. That's an indication that we've run out of possible factors to use. So sometimes we won't get a result. All right, just as what we've seen in the previous video, we might also be able to factor out some common factor from every term. So in this example, we're given 4n cubed minus 12n squared minus 40n. Notice it's not in the form x squared plus bx plus c. We have a cubed term and then a second power term plus this number in front. But notice they all have an n, so we can factor an n out in front of everything, and they're all divisible by 4 as well. So let's think about what should be left over. I took the 4 out, and I took one n, so there should just be two n's left. And then negative 12 divided by 4 is negative 3. And it was n squared. I took one n out, so there should be one left over. And then negative 40 divided by 4 is negative 10. And then I took the n. So we'll just have minus 10 there. Now notice this is in the form x squared plus bx plus c. We just have n instead of x. So let's factor this one using this method. We're looking for factors of negative 10 that add up to negative 3. So that could be 1 and negative 10, or 2 and negative 5. If I do those two, 2 minus 5 is negative 3. So that means we still have the 4n in front, but then that set of parentheses will factor into n plus 2 times n minus 5. So just check first if there is some greatest common factor that you can factor out of every term. Our last example is when we have two variables in our expression. Let's look at x squared plus 12xy plus 32y squared. And we're trying to view this as x squared plus something times x plus something else. So we can still basically do that here. If we see this as x squared, we have 12 times x times y. We can view this as like 12y times x. And then that last term is just 32y squared. Notice this term doesn't have an x in our form. So in this case, our c value is this entire 32y squared, and our b value is 12y. So let's see if this will work using this as our c and b value. We'll be looking for factors of 32y squared, two things that multiply to that add up to 12y. That means both terms should have a y, so when they're multiplied we get y squared, and when we add them we have some y term. So let's also consider factors of 32. So we have 1 and 32, which means we could have 1y and 32y. Those would multiply to 32y squared, but we wanted to add up to 12y. So then 32 is divisible by 2, so we could say 2y and 16y. That would add up to 18y. 32 is 4 times 8, so we could say 4y and 8y. And notice when we add these together, we get the 12y that we're looking for. So our two factors that we're looking for are 4y and 8y, meaning this original expression can factor into x plus 4y times x plus 8y. So let's multiply it out just to be sure that this works. So foiling this, our first terms multiplied would be x times x, so x squared. Then our outer terms, x times 8y, so that will give us 8xy. Then our inner terms, 4y times x, so plus 4 times x times y. Then our last 4 times 8 is 32, and y times y is y squared. So adding those middle terms, we get x squared plus 12xy plus 32y squared, which was our original statement here. So it works with multiple variables. Just try to get it into this form. We have x squared plus something times x. In this case, that something, that b term was 12y. And then plus the term that doesn't involve x. Our c term is 32y squared. All right, so we covered that skill of finding two numbers that multiply to some number that add up to some other number. We saw that that was useful in factoring a trinomial in this form, x squared plus bx plus c. I should note this won't work if we have some number in front of the x squared. We will actually cover that in our next video. We'll call that an a term. So in this case, if it's just 1, just have x squared, this process will work. Then we saw that additional example where we could factor something out of every term. And then our last example when we had two variables. Okay, that'll be it for this video, and I'll see you next time.